All right, y'all. So this is going to be my lecture over mathematical reasoning, chapter 2, A, B, and C. So I'm going to share my screen so y'all can watch me write my notes and work through the problems. All right, so chapter 2, A, B, C. So the first thing we show you is the three-step problem-solving method. Okay, so step number 1, understand the problem. What's the problem asking you to do? So understand the problem. You know, what are they wanting me to do? What kind of units will I end up in when I'm done? Okay, what kind of units are they giving me when I start? All right, then you try to solve that problem. All right, can you solve it without math? Do you need math to solve it? Do you have equations that help you solve these problems? Are there unit conversions that can help you solve the problem? And so on. And then the last step, explain your result. So did my answer make sense? Did I end up with the right units that I should have? If they ask me for something, how much is something, I should end up with dollars. If they ask me how far is something, I should end up with some kind of length, okay? So let's talk about units because I was saying that word a few times. So units to me, they describe what a quantity, that's an amount of something. So a quantity is an amount of something, measures or counts. So examples of units could be grams, that measures weight, feet, feet measure length or distance, seconds, seconds measure time. So they sort of let me know what I'm dealing with based on these units, okay? Now, unit analysis. Unit analysis, that is the process of working with units to help solve problems. So what I mean is, we know that when you're driving, you got a speedometer, right? And that speedometer tells you how fast you're going. Now your speed, when you're riding a car, we use what? Miles per hour. So this per means division, okay? Anytime you see per, it means division. So two keywords, per equals division, of equals multiply. So if we see any of them kind of words when we're talking, we know what they mean, okay? That's like percent means you divide by 100. That's how they get them decimals. So this is miles per hour, right? Well, miles measures distance or length. Hours measures time. So now we know the formula for speed just based on the units, okay? So that's what they were talking about. It's a process of working with the units to help me solve the problems by knowing what their formulas are. Okay, so what we're going to do at this point, we're going to do a little review on fractions. Because some of these formulas I'm about to use later on deal with fractions, and you got to know how to sort of work with them, okay? So first we will add or subtract. So adding and subtracting, if I had 1/5 plus 2/5, fifths. So the main thing adding fractions is they got to have a common denominator. So these ones already have a common denominator of 5. So that means your answer has to have the same bottom as the common denominator was. Now what you do, since this is two fractions being added, all the adding gets done to the top. You never add the bottom. It always stays whatever that common denominator was when you're adding. But then the tops do get added. So you go, okay, 1 plus 2, that's 3. Whoops. So my answer is a 3/5. So let me do one subtracting. How about 7/9 minus 2/9? So 7/9 minus 2/9, they have a common denominator. So my final answer when I subtract will have to have that common denominator. Now, just like adding, all the subtracting gets done on the top. So 7 minus 2 gives me 5. So my final answer is 5/9. And notice, neither one of these answers reduces, so I would stop there. They only reduce if you can divide a number out of both the top and the bottoms, okay? So now, I'm going to add or subtract again, but watch these problems. 1/2 plus 1/3. So these ones cannot be added yet because they don't look the same on the bottom. So you want to find the common denominator, which is the smallest number that 2 and 3 will multiply and go into. Okay, so 2 times 3 make a 6, and 6 is the smallest number that'll have factors of a 2 or a 3. Okay, so my LCD is a 6. So what you do, since this one has a 2 on the bottom, you need to multiply the 2 by 3 to make a 6. So since you multiplied the bottom by 3, you got to multiply top by 3. Whatever you do to the bottom, you do to the top. So 3 times 1 on top is a 3 over 3 times 2 is 6 on the bottom. Now the second fraction had a 3 there. So to turn the 3 into a 6, you would multiply that and by the 2, which means I got to multiply top by 2 also. So the second fraction, 1 times 2 on top is a 2. 3 times 2 on bottom is a 6. Now, they both look the same on the bottom. So when you add, the 6 comes over. That's the common denominator. And then all the adding gets done on the top. So 3 plus 2 is 5. So notice, I couldn't add them when I had a 1/2 plus a 1/3. I had to make these bottoms match in order to add them together. Now, that answer will not reduce. And then if you notice, that's it, y'all. Change the fractions by multiplying the top and the bottom by the same thing. Once they match, add them. And remember, that first step, you better keep that denominator the same as it is on both of those fractions. So, of course, I'm going to subtract another one. 4/5 minus 2/3. So, just like adding, subtracting, they got to have a common denominator. So, those ones, I'm going to find the smallest number that 3s and 5s will multiply and go into. And that looks like that's going to be 15. And really, all I did was multiply 5 times 3 and got 15. And there's no number smaller than 15 that'll divide by both the 5 and a 3, right? 10 will divide by 5, but it won't divide by 3. 5 would divide by 5, but not by 3. So 15 is the smallest number. So we got to change both of these so that they got a 15 on the bottom. So since the first one had a 5, we'd multiply top and bottom by a 3. That way the bottom has a 15. The top, 3 times 4 is 12. Bottom, 3 times 5 is 15. That's going to be minus my next fraction. It had a 3 on the bottom. To turn the 3 into 15, you would multiply by the 5. So the 2 gets multiplied by a 5. So let's see what we get. 2 times 5 is 10 on the top. 3 times 5 is 15 on the bottom. Now I can see that they have a common denominator now of 15. So my final answer on this step will have a 15. And then all the subtracting gets done on the top. So 12 minus 10 is 2. And y'all, guess what? 2 over 15 does not reduce. So that would be the final answer. So ought to be bringing back memories of fractions, I hope. So now let's multiply. So to multiply, I got 1/3 times 2/5. Multiplying is the easiest thing you're going to do with fractions because all you got to do is multiply the top times top and put that over the bottom times the bottom. So there's my fraction bar. On top, I got 1 times 2, which is 2. On bottom, I got a 3 times 5, which is 15. All right, how about another one? 3/4 times 5/3. All right, so first step would be to multiply. 3 times 5 is 15. 4 times 3 is 12. Now notice 15 and 12 will both divide by the same number. So to reduce that, you would divide them both by 3 because 15 and 12 will both divide by 3. So that 15 divided by 3 is 5. 12 divided by 3 is 4. So I'm going to show y'all a trick. When you first started this, when you had 3/4 times 5/3, what you could have done is simplified before you multiplied. See, you got a 3 on top here and a 3 on bottom. Anything on top that matches anything on bottom, they divide and make a bunch of 1s. Now, the 5 and 4 won't reduce, so that means when I finish multiplying, I'll be done. Watch this. 1 times 5 is 5. 4 times 1 is 4. I still get my 5/4 answer. So notice, you either divide those 3's out here with the big numbers, or you can divide them over here while they're still small numbers, okay? All right, so multiplying ain't bad. Multiply straight across. If you got to reduce them, that's how you would reduce them. All right, division. Division really ain't bad. You just got to remember, when you got something like A over B divided by C over D, what you got to do is bring the first fraction over, A over B, change the division to multiplication, and then you flip the second fraction so that the D is on top and the C is on bottom. Now, once you got it looking like that, multiply straight across and get your final answer. So division, write the first fraction. Change from division to multiplication. Flip the second fraction. So here we go. I got a 10 divided by 1/2 equals. Now, I will say, since a 10 don't look like a fraction, if you really want the 10 to look like a fraction, put a 1 under it. 10 divided by 1 is 10, so you're not changing the value. But we are going to change this from division to multiplication. So here we go. We're now going to have 10 over 1, change from division to multiplication. Flip the second fraction, so you get a 2 over 1. So now we got to multiply straight across. 10 times 2 is 20. 1 times 1 is 1. And y'all, anytime you get a 1 on the bottom, 20 divided by 1 is 20. If you get a 1 on top over a number, you got to keep the 1. But if you get a 1 on the bottom, we don't write that. We just write what number it is, okay? All right, one more division. 3/4 divided by 2/5. Now, what's nice about this one, you see how you think you got a 2 and a 4 that reduce? You cannot reduce while you're dividing. You got to change it to multiplication before you see if there's anything that you can reduce or cancel, okay? So we first got to change this to multiplication. So I bring over my 3/4, change from division to multiplication, flip my second fraction so I get a 5 over 2. So notice the 3 won't reduce, the 5 won't reduce. So since none of my numbers on top reduce with either number on the bottom, this answer will not reduce when I'm done. So see, you couldn't have reduced over here. You gotta change it to multiplication before you try to reduce. So nothing reduces, so I'm going to multiply straight across for my final answer. 3 times 5 is 15. 4 times 2 is 8. That does not reduce. Final answer. All right, so let's play with a little bit of that unit conversion. Now, I emailed y'all a helper sheet for your unit conversions last night. So we're going to convert numbers from one unit to another unit. So convert numbers from one unit to another unit. So my first example, I'm going to turn 2 feet into inches. Now, if you look on the sheet I gave you, you'll see that there are 12 inches equal to 1 foot. Okay, but y'all remember that from growing up, right? So what they give me 2 feet to start with. So I got my 2 feet. So remember, on unit conversion, we draw our little boxes, and anything on top is multiplied. Anything I put on bottom will be divided, okay? So now we're trying to get rid of the feet, so the feet got to go to the bottom. So 1 foot will go to the bottom, and for every 1 foot, we know that that is 12 inches. So since I wanted to end up with inches, I needed my inches to be on the top when I'm done. You always need to counter place whichever unit you got to cancel, because now these feet, since one's on top and one's on bottom, you cancel them out. The only units left is your inches, so your answer is going to be in inches. And then the top, everything up here gets multiplied. So 2 times 12 is 24. And then you divide by the one on bottom. But 24 divided by 1 is 24. So 2 feet is 24 inches. All right, y'all, how about the next example? 4 grams to milligrams. So the conversion on that, and we'll learn that in just a second, but there are 1,000 milligrams equal to 1 gram, okay? Remember, milligrams are a lot smaller than grams, so it takes 1,000 of these, and I'll show y'all in a little bit when I break out our metric conversions, okay? So this was on the chart, I think. So we start with our 4 grams, and we're going to try to convert the grams into the milligrams. So since grams are on top, I got to put the grams on bottom. So down here you would put 1 gram is equal to 1,000 milligrams. So look what happens. The grams are going to cancel. So when I'm done, my units will be milligrams. All we do is multiply the top. 4 times 1,000 is 4,000 divided by 1, which will stay 4,000. All right, one more. So y'all get an idea how I'm getting these units done, right? So we're going to turn 4 hours into minutes. So I do know that there are, what, 60 minutes equals 1 hour. We know that conversion, so let's turn these hours into minutes. We start with our 4 hours, draw all our boxes, and we're trying to cancel the hours, so the hour goes to the bottom, and the 60 minutes goes to the top. See how the hours now cancel? And all we got to do is multiply 4 times 60, and we get 240 minutes. because that's the units I had left when I was done. And then I was dividing by 1 again, so that didn't change my answer, okay? All right, y'all, let's see. So I'm going to look at some of the tables here. So these are examples from table 2.2, 2.3, and 2.4 that are in your PowerPoint notes that I sent. There's some tables in there. Well, they're even in the book. And I actually gave you a page with those tables on it. I'm trying to find mine. Oh, here it is. This page right here that I sent you on your email has these 3 tables. Table 2.2 is just giving you unit conversions. Table 2.3 is giving you metric system prefixes. And then my table 2.4 just has some US conversions going into the metric system, okay? And then over here is a currency table they gave us for the British pound, Canadian dollar, European euro, Japanese yen, and the Mexican peso. So if you know their amount, like say you have 350 pesos, you convert that to American by using this. If you know how many dollars you have in US dollars, you would use the foreign per dollar conversion to turn our money into their currency amount, okay? So I think I was going to do a few examples on that using this little table. Now, I sent you a copy of this table in your email last night. So these examples are currency, exchange, rates. It's doing the same thing I've been doing, just with money. So number 1 wants me to convert 85 euros into dollars. So let me get that conversion for those euros. European euro. I know theirs, I want to turn it into dollars. And this is if I know ours, I want to turn it into my dollar. So let's see, I know theirs is 85 euros. So y'all look here. Since I know theirs is 85 euros, I come down here to the European euro, and I'm going to use 1.058 as my conversion factor because I know theirs and I'm turning it into ours. So I'll start with my 85 euros. And this is telling me that let's see, 1 euro from that chart we said was what? 1.058 US dollars. Okay. So we started with 85 euros. We know that 1 euro is equal to 1.058 US dollars. So once you figure out your euro, if you're going from theirs to ours, you put the decimal with the money. If you're doing it the other way, from American dollars to the euro, then you'll put that decimal with the euro part on it, okay? All right, so watch this. Euro cancels, and all I got to do on this calculator is figure out what 85 times 1.058 equals, and that's going to give me $89.93 left in my units of dollars. All right, so watch this next one. We'll mess with the pesos now. We're going to convert $100 to Mexican pesos. All right, we're going to put my chart right here. It is. So let's see. For the peso, we want our dollars, which we know our amount. We're going to go from foreign per our dollar. Okay. So for the peso, our exchange rate is down here at 21.86. So watch this. So dollars equals 21.86 pesos, right? Oh, hold on. Yeah, hold on. Yeah. All right, here we go. $100 in American. And I want this to end up as pesos, right? So over here we said these dollars equal 21.86 pesos. So I want to cancel the dollars. I got to put the dollars on the bottom, and then the 21.86 pesos goes to the top. So see the difference here? When I was converting from euros to money, the number went with the money. When I'm converting from our money to their currency, the number goes with their currency. Because see what happens? My dollars cancel. So let's multiply and see how many pesos that is going to equal. And y'all, that equals 2,186 pesos. Well, that's why it takes a lot of pesos for our dollars. To where up here, if you notice, for 85 euros, our dollar was a little higher. Okay, so the euro must be a little stronger than the dollar, but the dollar is a lot stronger than the peso, okay? All right, so that's just a little bit on playing with some of those conversions. Next, I'm going to play with the metric system. And we're going to talk about different units. So for length or distance, metric system uses the meter, or that could be a M. For mass, or mass is your weight, which is how much something weighs, they use the kilogram or the gram. Okay, kilogram or gram. For time, everybody uses the second, or sometimes you might see it used with the hours, but that's common practice there. And then volume, you are used to gallons and quarts. In the metric system, it is the liter or a L, okay? Now seconds could be a S. They use a little S. I forgot to put that there. Or hours might be a H and a R, okay? So let's look at the metric system. So our base units are going to be either the meter, the gram, or the liters, right? Those are going to be our base units. So we're going to just play with the meter, okay? So in the very middle is your meter, your gram, and all that fun stuff. So the metric system increases by powers of 10 between each unit, to where inches to feet, well, there's 12 inches in a feet, 3 feet in a yard. Metric system didn't like that. They wanted to increase everything by powers of 10. So here you got a meter. If you multiplied 10 meters, 10 times a meter would give you 10 meters or 1 decameter, which is abbreviated DA, deca. So you have a decameter or a decagram. That means that this is 10 meters, because you multiply by 10 to go from a basic meter to a decameter. Now, 10 of these decameters make what we call a hectometer, which is a H. So to go from a deca to a hecto, you would multiply by 10, or to go from a meter to a hecto, you would multiply by 1 100. Okay, because remember it's times 10 each time, and 10 times 10 is a move of a 100. Next, y'all got your kilogram. That is kilo, or kilometers, kilometers, right? So to go from a hecto to a kilometer, you would multiply by 10 again. To go from a meter to a kilometer, you would multiply by 1,000. 10 times 10 is 100, times 10 is 1,000. See, these keep going up by factors of 10. Next would be mega, which is a big M. Megabytes, right? Y'all know all that stuff on them cell phones. So mega would be going from a kilo to a mega, actually goes by 1,000 now, okay? So they just went by tens down here, but when you get to these big, big units, they go by thousands. So to go from a meter to a mega, you're going to multiply by 1,000,000, okay? Next you have giga. Y'all know giga. Y'all want gigabytes on them phones for sure. The more G's, the more better. But that would be going from a mega to a giga is times another 1,000. So going from a meter to a giga is like multiplying by 1,000,000,000, right? Millions, billions. I mean, y'all, that's a lot of zeros, right? Right, there's one more called Tera, but I'm not going to worry about it. Now, going up in powers, this is 1 here. This would be 10 to the first, 10 to the second, 10 to the third, 10 to the sixth, and 10 to the ninth. Tera up here would be a T, and that's 10 to the 12th. So you would actually have to multiply by a, what is that, trillion or so to get that big of decimals, okay? All right, they go the other way also. Instead of multiplying by tens, we can divide by powers of tens. So 1/10 of a meter is what we call a decimeter, a little d. So deci's a d, deca is a da. That's like 1/10, okay, to the first, or 10 to the negative first. So anytime you're dividing by the 10 like this, you can write it as a negative exponent. Okay, so that would be dividing by 10. To go from decis to centimeters, which is a C, you divide by another 10. So here you're multiplying by tens, here you're dividing by tens. Or I could start with the meters and divide by 100. So everything I did on this side, multiplying by them hundreds, I can do on this side. Next is the milli, little m, which is dividing by another 10. Or if you started at meter, dividing by 1,000. Same thing going that way, right? So this is 1/100, or 10 to the negative second. Milli is 1/1,000, or 10 to the negative third. All right, you got a few more. Now these start increasing by dividing by 1,000, just like these were multiplying by 1,000. Now I'm not going to write all these arrows over here, but you're all going to get the idea. Micro, which is usually the Greek mu, or you can see it be a MC. Micro is 1/1,000,000, or 10 to the negative 6. Nano is an N, that's 1/1,000,000,000 now, or 10 to the negative 9th. Oh, and then the very final one is pico, which is a P. That's like 1 over, let's see, that was what, million, 1 over a trillion now. That's like 12 zeros. Or 10 to the negative 12. You see how these exponents tell me how many zeros are down here on these numbers? 6 zeros, 9 zeros, 12 zeros. Up here, these would be the same thing. 10 to the ninth would be like a billion. That would be like a trillion. That'd be like a million. 10 to the third would be 1,000. 10 squared would be 100. 10 to the first would be 1, right? So that's sort of like their values in the real world. All right, so let's see what we're going to do knowing this information. So example, convert 2,759 centimeters to meters. All right, so I'm going to start with my 2759 centimeters. Now I'm going from centimeters to meters, so I know if you look at my chart I just made you, there is 100 centimeters for every 1 meter, right? Since you had to divide by 100 to go down that way, you have to multiply by 100 centimeters to get back to 1 meter. So here we go. We got 100 centimeters is 1 meter. All right, so all we would do is take the bottom, which is the top, which is 2,759, divide that by 100, and I get 27 point. So let me round to the nearest. Oh, that ain't bad. How about 59? Now, if they did want me to round to the nearest tenth, that would have been a 0.6. And remember, since the centimeters left, I'm now with meters. So they're telling me how long something is, right? All right, so watch this one. How many nanoseconds in a microsecond? So I'm going to compare my nanoseconds to my microseconds. And nanoseconds, if we remember the chart I just made y'all, are a lot smaller than microseconds. So I'm going to put my microseconds on top and divide by my nanoseconds, right? So 1 microseconds, I'm going to divide by my 1 nanoseconds. Now on the chart I told you the microseconds is 10 to the negative 6. The nanoseconds is 10 to the negative 9th. So now remember, when you got exponents, when the bases match, you subtract the bottom exponent from the top. So I got this 10 to the negative 6 minus the negative 9. That's why I used the parentheses, just to separate my signs. Those two negatives make a positive, so you now have negative 6 plus 9. Negative 6 plus 9 gives me 10 to the third, and 10 to the third is equal to 1,000. So there's 1,000 nanoseconds in a microsecond. But we knew that because we said to go from a micro to a nano, you had to divide by 1,000 anyway, right? All right, here's another example of our charts. There's a race, a marathon. A marathon is 26.2 miles. How many kilometers is that? So we got to go from miles to kilometers or kilometers. So if you notice down here on the bottom, this chart had the US to metric, and down here you see that 1 mile equals 1.6093 kilometers. So 1 mile equals 1.6093 kilometers. So that's what we needed. So we start with our 26.2 miles. And remember, I need to cancel the miles, so that miles needs to be on the bottom. So here we go, 1 mile. And then the 1.6093 kilometers is on the top, and that's all I needed, right? The one conversion. So my miles will cancel. So to finish this, I'm going to do 26.2 times 1.6093. So once I hit enter, I get 42.16. I'll just round to the nearest hundredth on that, which is 2 decimal places. So just remember how whatever they want you to do, round that many units, okay? All right, let's get another one on this page real quick. How many square kilometers? So how many square kilometers? And that could be km squared like that, or in a square mile. And that could be like a mile squared, okay? So watch this. I had a conversion up here for 1 mile equals 1 kilometer. So 1 mile equals 1.6093 kilometers. So if I want to change my units from kilometers to kilometers squared, I got to square everything in each side. So 1 mile, if you square that 1 mile, you'll get 1 mile squared. This side's a little different because you do have a different number than 1. So you want to square that 1.6093. Square that, and on the calculator, you can square it by just hitting the X squared button and hit enter. Whoops, what did it say? What I did here? All right, let me do that again. 1.6093 squared. I must have hit the wrong button down there somewhere. When you square that, I'm going to round that off to how about a 2.5898. I'll just round 4 decimals on that, just like they had 4 up here, okay? But this is now kilometers squared because you had to square that whole thing. Square the number, square the kilometers. So this is now our conversion. So we're starting with a square mile. So 1 mile squared. Right here we got a conversion, 1 mile squared. Whoops, let me bring that down just a little bit for this one. So 1 mile squared equals 2.5898 kilometers squared. So when we're done, our answer will be kilometers squared. We just need to find our number. And look, 1 times 2.5898 is going to be 2.5898 kilometers squared, which is roughly 2.6 square kilometers. I got to watch that on there because sometimes I get writing down too low, okay? So there was all the notes from that. So next, I'm going to show you a few temperature conversions. So there's 3 temperature scales we look at in the world. First one most of us know is the Fahrenheit. But we have another scale called Celsius. And we even have another scale called the Kelvin. So what we did, we know that in Fahrenheit, boiling is 212 degrees Fahrenheit. In Celsius, boiling is 100 degrees Celsius. In Kelvin, boiling is 373.15 Kelvin. And I'll do it again, didn't I? And I'll explain how they got this Kelvin scale in a little bit. Now let's look at the freezing. Freezing for Fahrenheit is 32 degrees Fahrenheit. Freezing in Celsius is 0 degrees Celsius. Freezing on Kelvin is 273.15 Kelvin. Now, to understand Kelvin, we deal with what we call absolute zero. Absolute zero is like the coldest temperatures recorded. Absolute zero in Fahrenheit would be negative 459.67 degrees Fahrenheit. Nothing moves at that temperature. That's where motion is just not existing. Celsius would be a negative 273.15 degrees Celsius. And on the Kelvin scale, it is 0 degrees Kelvin. Which means, well, Kelvin don't use the degree, I don't think. Which means that absolute zero is the freezing point on the Kelvin scale. So it starts there, and then it goes up just like the Celsius scale. See, this is negative 273. You add 273 to 0, or you add 273 to the Celsius, you get to 0. And then from 0 to 100, this one goes up from 273 to 373. So it's basically the Celsius scale toned down to start at absolute zero instead of the freezing point of water. Okay? Now, you got some conversions you can use. So for Fahrenheit, the formula is 9/5 C plus 32. Whoops, my C is a little crooked there. But that would be C like the Celsius degrees plus 32. Or if you like decimals better, you can do F equals 1.8 times your C plus 32. So either multiply by a fraction times the C or a decimal times the C. Now we can go to Celsius. Celsius equals 5/9 parentheses Fahrenheit minus 32. So this one you multiply first, then add 32. This one you subtract first, then multiply by the 5/9. Now, if you like decimals on that would be C equals F minus 32 divided by 1.8. And then I guess if you want to do Kelvin and Celsius, Kelvin equals Celsius plus 273.15, or you can do Celsius equals Kelvin minus the 273.15. Alrighty, so let me see. Well, let's do one of these. Let's convert. How about 20 degrees Celsius to Fahrenheit? So to go from Celsius to Fahrenheit, I'm looking for the Fahrenheit when I know the Celsius. So either one of these formulas would work. I'm going to use the fraction one, but you could use the decimal one. So I'm going to use my Fahrenheit equals 9/5 times my Celsius temperature, which was 20 degrees Celsius, right? Plus 32. Now you don't have to write the Celsius in there because when you're done, you're just going to get a number on here. So to do this, to make the 20 look like a fraction, you can put a 1 on the bottom. Now, you can multiply first on the top, then divide by the bottom, or you could reduce this top and bottom because they will reduce. So I'm going to reduce mine. 20 divided by 5 is 4. 5 divided by 5 is 1. So now I got on the top, 9 times 4 is 36, divided by 1. 36 divided by 1 is 36. Then I bring over my 32. Then finally I add 36 plus 32 and I get 68. So 20 degrees Celsius is the same as 68 degrees Fahrenheit. So you just use these formulas to convert from one way to the other, okay? So That's almost room temperature for me, right? 68. I like it about 68, 69. So I know I like it around, what, 20 degrees Celsius in my house. All righty, another one. Um, let's go from Fahrenheit to Celsius. So we know water freezes at 32 Celsius. So let me do one more over here. So let's convert 32 degrees Fahrenheit to Celsius. So to go from Fahrenheit to Celsius, I'm going to use my Celsius equals 5/9 F minus 32. Now remember, you could use the other one with the decimal I gave you where you do the F minus 32 divided by 1.8. But this don't bother me. So you got to do the parentheses first. So bring down that 5/9. Replace the F with a 32. So now, parentheses first, bring down to 5/9. All right, 32 minus 32 is 0. And y'all look at that. 5/9 times 0 is 0. So 32 degrees Fahrenheit is equal to 0 degrees Celsius. And we knew that because we had that on our chart a while ago, right? So since we had it on that chart, we knew that it was going to give us what we needed. All right, so my final problem, I like this one. It's in one of your homework problems. Let me move the calculator over there a second. So I'm just going to read this to you first. Suppose that 8 turns of wire, so I'll put that 8 turns of wire, are wrapped around a pipe with a length of 60 inches and a circumference of 4 inches. So that the wire reaches evenly from the top of the pipe to the bottom. So they got a pipe and they just round the wire around it. They want to know what is the length of the wire. So let me draw what I got. Here's my pipe. So I got me a pipe. Circumference is how round that is. So they said that was 4 inches. They said it was 60 inches long. So I used them 2 little hyphens for my inches. And what they mean by wire wrapped around it, they got a wire and it just keeps wrapping around it 8 times. Okay, you got a wire wrapping around that 8 times. So they sort of give you a clue on this one to answer it. In MATLAB, they tell you to cut this and open it out and make it look like a box. So if you cut that out and made it look like a box by cutting it down the center and just opening it up, this length would be 4 inches. And we know this whole side is still 60, but now we got our wires turning like this. Now I might not get 8 on here, but y'all get the idea. But look, if you draw little lines like that, look what I got. I got a whole bunch of triangles going on. I know this side is 4 inches. I know this side will be 60 inches divided by 8 because I had 8 turns, right? So that means this is going to break this into 8 sections. So if we do 60 divided by 8 to get them 8 sections, that's going to be 7.5 inches for each of the sides. So 7.5 inches. So what we're looking for is this wire coming around. So we know this distance. We know this distance. I'm going to solve this using the Pythagorean theorem. Pythagorean theorem says a squared plus b squared equals c squared. Now, c is this longest side right here. We call that the hypotenuse. That's always the c. So that's what we're solving for, basically. So to solve this c for the c here, you got to take square roots of both sides. So that C will equal the square root of the A squared plus B squared. So treat this stuff inside like it's in parentheses, figure that out, and then take the square root of that number last. So 4 could be my A, 7.5 can be my B. So the answer for my C, I'm going to take the square root of A squared, which is 4 squared, plus B, which is 7.5 squared. So watch this on my calculator. If you want to do it by hand, first thing I would do, whoops, I said square, man. Why did I write my inch symbols? I'm losing it. Squared, right? A squared, B squared, 4 squared, 7.5. So 4 squared is 16 plus 7.5 times 7.5, which is 7 squared, gives me 56.25. Next, I would add them up and keep that under that radical. So 56.25 plus 16 gives me 72.25. Then my final step, I would take the square root, second, x squared over here to get that radical. And then 72.25 equals 8.5. So remember, 8.5 is each of these sections of wire that I found. But I had 8 turns, so I got 8 of those. So for my total wire length, it'll be 8.5 inches times the 8 turns. So ever how many turns you have is what you divided that length by to get each section. So now we got to compensate that we did have the 8 sections. So 8.5 times 8 gives me a total length on my wire of 68 inches long. Okay, y'all, so they're not bad. You just got to get in there and figure out what they're asking you for, and do I have some kind of formula that I might have learned in life to figure this out. So when they told me to sort of open it up and cut it down the middle to make it look like a square, and they said to make them diagonals for the turns, they're trying to get you to remember that makes a triangle. And the easiest way to solve sides of a triangle is with the Pythagorean theorem, and I'll actually write that. Pythagorean theorem. All right, y'all, so I'm going to end this because that's all the material for 2, A, B, and C that I'm going to do with you, okay? And then next I'll get into chapter 3 material. So I did send another video doing the homework on 2A, B, C. That'll help you do the homework. All right, y'all. Have a happy weekend, and I'll see y'all later.